The photovoltaic effect was discovered by the French physicist Alexandre Edmond Barquel in 1839, but solar energy was not used for power until 1941, when Russell Ohl invented the solar cell. These solar cells, or solar panels, work by light or photons hitting certain compounds, which causes the surface of the panel to accept the electrons. The combination of light striking another compound causes electrons to flow through a conductor, which creates electricity.
A passive solar building will simply, passively sit where it is located and be efficient because of its design. The design is based off the movements and available energy of the sun, as well as the materials used to construct it. Active solar heating and electrical systems also use the sun's energy, but with additional mechanical means used in the process of harnessing its energy. Photovoltaic panels, pumps, thermostats, and fans are objects that are commonly referred to as being active solar because they need some electrical input or conversion for their systems to function. Cities are always looking for ways to create practical sources of energy. In the process, cities evaluate other cities of the similar size and their successes with uses of forms of new energy. At some point, if a city finds a new source of energy feasible, then they take steps to implement that source. This is the challenge with solar energy. In Texas, there are issues that have halted solar energy. The heavier reliance on fracking, lack of strong public policy, and a deregulated energy industry have put a hold on solar energy in Texas cities like Kerrville. For this project, we interviewed Mike Whitler, General Manager and CEO of the Kerrville Public Utility Board, to answer a few questions about the solar energy project in Kerrville.
What are the pros of solar energy in Kerrville for humans and the environment?
So for KPUB, our primary driver on this is actually economics. The solar energy and renewables in general have come down in price to where they're competitive with traditional fossil fuel sources. Now, in addition to that, they're considered renewable, so you have zero emissions and other benefits there as well.
And what about the cons?
So cost is in line with traditional resources. A typical fossil fuel energy right now costs about 4 cents a kilowatt hour. This is actually costing a little more than that, more like 6. But there are some benefits to having it installed on our local system, and so that offsets that difference, where this effectively becomes 4 cents a kilowatt hour. Let's talk about full life expectancy of the system here. I would expect this system to be running for 30 to 40 years. The cost of the panels is about, for this scale of a system, so if you're doing about a megawatt or 1 to 2 megawatts, the cost of the entire system is about $1.50 a megawatt. This system here is 1.5 megawatts, so this is about $2.25 million to install this system here.
Wow.
If you go to rooftop scale systems like you'd have on your house, then the price goes up to $3 to $4 a watt to install that there. So when you look at the cost of energy, this system is going to cost about half what it would for a system on your house. There at this site, there were a lot of trees here, so there's an environmental trade-off. There were this had trees just like there are on the back side of the system. The other sites didn't so much have the trees. Otherwise, I don't think the impact is all that great. They don't change your water rate runoff really. There's a little bit of hydraulic fluid to help to operate the tracking systems, but all in all, I think they're fairly neutral. The way we're serving those customers is we call it virtual net metering, and so they will pick the meters that we allocate the energy to, and so say the field has 2,000 panels on it. Schreiner gets credit for 1,000 of them, and they can pick individual buildings and say, take the output from 10 and assign it to this building, and I want 20 assigned to this dorm and 50 assigned to the library. and then we automatically take care of the billing and give them credit for the energy that's produced. So they will choose which buildings get the energy, and I can tell you what they're going to do is they're going to look at the buildings with the highest energy cost and assign the solar to those buildings.
Why are solar panels, like in your opinion, not widely used in Kerrville?
It's the economics. So, and that I mentioned that earlier, but the price of energy when you put a system in this size is about 6 cents a kilowatt hour. But on a rooftop size system, which most people would be installing, it's more like 12 cents a kilowatt hour. And our residential rate runs between 7 and 9 cents. So if you chose to put solar on your house, it would cost you more money than buying from the utility. And that's why when most people look at it on our system, it doesn't make sense.
So what do you think the future of solar panels is for Kerrville?
I think, so they're really booming in Texas, and we've actually signed some bigger deals too. They're putting in much larger systems, typically in West Texas. So we went in with a group of 5 cities, and K-Pub's getting 75 megawatts of solar. So we're getting the equivalent of 50 times the size. The price on that is much, much lower. It's probably a third the cost of this one. But there's tax credits that are falling off, and so I think prices are going to start going back up. And there's also so many of the systems going on to the grid that we're having other technical challenges with deploying more solar.
Wow. They don't even look like solar panels.